All right, let's get right into it. If you've ever looked at a big corporate network and wondered how on earth they keep it all running smoothly and, securely, then you're in the right place. We're about to pull back the curtain on one of the most fundamental tools out there, the virtual LAN, or as you'll always hear it, the VLAN.
So I want you to imagine your entire company works in one giant open plan office. I mean, no walls, no cubicles, nothing. Now, somebody in sales shouts a question across the room. Who hears it? Well, everybody, right? The engineers, the accountants, the R&D team. Everyone has to stop what they're doing for just a split second to figure out if that shout was for them. Most of the time, it's not. That right there is exactly what a basic flat network is like. It's just plain loud and super inefficient.
So to really understand the solution here, we first have to get a solid handle on the problem. In the world of networking, that loud open plan office has a name. It's called a broadcast domain. A traditional local area network, a LAN, is basically just one big, single broadcast domain. So what does that actually mean in practice? Well, it means that certain kinds of network messages, which we call broadcasts, get sent to every single device on that network. It doesn't matter if they need the information or not. And this isn't just a waste of bandwidth, it's a huge security issue. It's just like having those sensitive R&D conversations out in the open, where literally anyone can listen in.
And this visual really drives the point home. You can see the chaos. When this one little PC sends out a broadcast, every other computer, every printer, every server plugged into that switch has to stop and look at it. Now, it might only take a tiny fraction of a second, but you have to multiply that by hundreds, maybe thousands of devices all chattering away. The end result? A sluggish, bogged-down network. This is our before picture.
Okay, so how do we fix this mess? We can't exactly start building physical walls in our server rack, but what we can do is build virtual ones. And that's where the hero of our story comes in, the virtual LAN, the VLAN.
And here it is. This is the aha moment. Take a look. The physical wiring, the switch itself, nothing has changed. It's the exact same hardware. But just by configuring VLANs, we've logically carved up the network. We've created different departments, sales in one color, R&D in another, and now, when that same PC sends its broadcast message, only the other devices in its own color group, its own VLAN, ever see it. Just like that, we've contained the noise.
So why does this one simple change matter so much? Well, the benefits are huge. Right off the bat, performance skyrockets because all those devices aren't wasting time processing traffic that has nothing to do with them. Security gets an immediate boost because the R&D data is now completely isolated and invisible to, say, the production network. And you get this incredible flexibility. A sales guy can plug his laptop in on the first floor or the 10th floor, and as long as that port is set up for the sales VLAN, boom, he's on the right network. It's brilliant. This all sounds great, but how does the switch actually pull this off? How does it know which data belongs to which virtual department? Let's take a look under the hood and see what's really going on. The real magic behind VLANs is a process called frame tagging. The industry standard for this is called IEEE 802.1q. It works like this. When a piece of data comes into the switch itself attaches a tiny digital tag to it. You can think of it exactly like a digital ID badge that says, hey, this data belongs to VLAN 10, or this one's for VLAN 20. The switch then uses that tag to make sure the data only ever goes out to other ports that are members of that exact same VLAN.
Now, this number you're seeing, 4096, this is where you really see just how powerful and scalable this system is. The 802.1q standard gives us space for 4096 unique VLANs. Think about that for a second. You could literally create a separate, totally isolated virtual network for every single employee in a 4,000-person company. It's that kind of scale that makes VLANs an absolute cornerstone of any serious network design.
Now, to make this whole tagging system work, switches have two main kinds of ports. The first is an access port. You can think of this like the door to a single office. It belongs to one and only one VLAN. This is where you'd plug in your computer or a printer. Then you have the trunk port. This is like the building's main elevator. It's a special, high-speed connection, usually between switches, that's designed to carry all the tagged traffic for all the different VLANs at the same time. And this quote from a network engineer named Farai just boils it all down perfectly. It really is that simple in concept. As the admin, your job is to assign the ports on the switch to the right VLANs. You're basically painting the doors the right color. Then, you just plug the devices into the ports you've already configured. That's the core of it.
Okay, so we've done it. We've built our virtual walls, our departments are separated, everything is running efficiently. But what happens when someone in the sales VLAN actually needs to send a file to someone in R&D? Well, by default, they can't.
By their very design, VLANs are isolated. So for them to talk to each other, the traffic has to be, let's say, escalated up the chain of command to a layer 3 device, which is usually a router. So the switch sees the traffic from sales as trying to get to R&D. It can't do it itself, so it sends it up to the router. The router then acts like a manager. It looks at the traffic, checks its rulebook, its access lists, and says, okay, is this allowed? If the rule says yes, it then routes the traffic back down to the correct destination in the R&D VLAN.
So let's bring this all home. Why is this concept, which has been around for decades, still the absolute blueprint for pretty much any modern network you'll ever come across?
Look, if you walk away remembering just a few key things, these are the ones. VLANs let you bring logical order to physical chaos. They turbocharge performance by stopping all that broadcast noise. They seriously ramp up security by segmenting the network into smaller, isolated chunks. And they do it all using a clever tagging system. And maybe most importantly, to get between those groups, you have to go through a checkpoint, a router that's in charge of the rule.
And that leaves us with one last thing to think about. We've successfully built the virtual walls between our departments. The noise is gone, but just having walls, that's not the whole story. The real heart of network security isn't just about separating traffic, it's about defining the rules for what's allowed to pass through those walls. So yeah, your departments are separate, but are they truly secure?